so let's start with Jade. Jade, go ahead and move so we can write down what like radicals are. Like radicals. It's a radical. Sorry. They have the same exact stuff, that's a technical term, under the square root, which the square root is called the radicand. Radicand. Like radicals have the exact same stuff, so same numbers, same letters, same exponents on the numbers and letters underneath their radical. And then Rob, when you get that written down, go ahead and see unlike radicals, so you can write that down too. You move it too far up it. Oh, okay. Let's pause the recording. All right, so unlike radicals don't have the exact same stuff under the square root, also known as the radicand. I find it ironic that we use the word stuff and the word radicand in the same very technical term and a very untechnical term. So what we're going to do is we're going to treat the radicals as if they were variables. So when we look at this expression here, 3x plus 5x minus 2y, I can combine together 3x's plus 5x's. Together they make 8x's, and I don't have any other y's, so the minus 2y just stays as minus 2y. It's the same with radicals. If I have 3 root 7s and 5 root 7s, and I'm minusing 2 root 5s, I can go ahead and do the math on the root 7. 3 plus 5 is 8. So this is 8 root 7s altogether, and that is still minus 2 root 5s. I can't combine the root 7 and the root 5 when I've got a minus or a plus in between. I cannot do that. It's the same as if I had 8x and a minus 2y. I can't combine those together. If it were multiplication or division, I definitely could do that, but with adding or subtracting, it's got to be exactly the same in order to combine them together. All right, so this is Paisley. 6 root 11s plus 9 root 11s is how many root 11s? 15 root 11s. And then Donna, 1 root 3 minus 3 root 3 is how many root 3s? 1 minus 3. Negative 2 root 3. And take a peek at this. Just like when we see an x. Oh, I'm sorry. 1 root 3 minus 5 root. Oh, okay, so it's 4. Sorry. Thank you, guys. Just like when we have an x hanging out with just itself, we know that the number in front of it is 1, but we don't write 1x. We just look at it and say that is 1x. And we know its exponent is 1, but we don't write power 1. So here the difference is, there is no difference between that and when we just have an x. 1 root 3 minus 5 root 3s is negative 4 root 3s. Okay, take 15 seconds and try these two problems. See if you can get the answer. 7 root 2s minus 8 root 2s is how many root 2s?
Negative 1 and then square root of 2.
Yeah. We can also write this as negative root 2. Same. We don't need, when it's just 1, we don't need to write the 1 in there. All right, Miss Layla. 5 root 5s plus 2 root 5s is how many root 5s?
7 root 5.
It is 7 root 5s. Not too hard, not too bad. All right, now we're going to combine what we were doing yesterday with this new information. I have a 5 root 3, and I'm minusing a root 12. So we're going to factor tree the 12. Richard, what are two factors of 12? 6 and 2. 2 is a prime number, so I'm going to circle it. And then Elijah, what are factors of 6? 3 and 2. So this is a little review from yesterday. When you don't know which perfect square lives inside as a factor of one of our numbers, you can always factor tree and pair it up. So my root 12 is the same as square root of 2 times 2 times 3. You're going to group the pairs together. And then let's go, this will be easy. Laura, and when I play row bingo, there's only one in there. I win every time, right? 2 times 2 is 4. What is the square root of 4? Square root of 4 is 2, so I'm going to cross out the 2 times 2, and I'm going to cross out the 4, and I'm going to move that to the front. And I have 3 left underneath the square root. So factor of 12 was 4. Square root of 4 is 2. I've moved the 2 out front. I'm left with 3 underneath the radical. So my new radical is 5 root 3 minus, instead of root 12, it's going to be 2 root 3. And just so I can get my bingo out of the way, Rudy, 5 root 3s minus 2 root 3s is how many root 3s?
3.
3 root 3s is my final answer. All right, you guys, give this a whirl. 7 is a prime number, so don't try to factor tree 7. He's just going to stay. But be detectives. If they say that 7, you know 7 is a prime number, guess what a factor is going to be left underneath this radical? 7. Okay, I'm going to give you guys 1 minute to try these two problems. Peyton, what magic perfect square lives inside of 28? 2. 2 is what we get when we take the square root. What is it before we square root it? 4. It is 4. 4 times 7 is 28. You can factor tree that out and see that, okay, this is 2 times 2 times 7. The 2's are buddies, they're pairs. So 2 times 2 is 4. Square root of 4 is 2. Make sure you don't lose this 2 originally. There's already a 2 there, and we're putting another 2 with it. Does that make 22? When I move that 2 out front, does it make 22? What does it make? It's 4. So we got a 4 root 7 from the first, right here. 2 times 2 is 4. And Peyton, 4 root 7 plus 4 root 7 is how many root 7s? 8. All right. 32. Some of you may look at 32 and go, I know what perfect square lives inside 32. It's 4. There's a bigger number. 6. What's the bigger perfect square that lives inside of 32? 6. 16. What? The way we find that is we go 32. 4 and 2 times 2. So 32 is 5 2's multiplied together. So we pair those up. There's 2 there. There is 2 there. Square root of 4 is 2. Square root of 4 is 2. And that's why we're using the 16. I'm going to erase this real quick. Because I think we're at the point now where we can go, what's the square root of 16? So the 4 is going to come out. And multiply by our original 5. What perfect square lives inside of 18? Eighteen is 2 times 9. Oh, 9 is our perfect square that lives inside of 18. So it's going to be so we're going to take the square root of that 9. It's going to become 3. And that 3 is going to multiply by the 4 that's out in front. Okay, let's simplify these numbers down. We have 20 root 2. And we have 12 root 2. And let's go back over to Leslie. Leslie, 20 root 2s minus 12 root 2s is how many root 2s? Yeah. It is 8 root 2s. All right. Give me 2 thumbs up, just like Fonzie. Yay. If you are ready to move on to the next one. And I just have the cheese. All right, so we did adding and subtracting just now. Now we're going to multiply. So the same rule applies. When we multiply radicals together, everything inside the parentheses is going to get multiplied by root 10. So it's called the distributive property. So it's going to be root 10 times root 6 and root 10 times 3. When we have 2 roots that are being multiplied together, we can write them as if they're underneath one radical. That's square root of 10 times 6. It goes underneath one radical. If we're adding or subtracting, we can't do that. But if we're multiplying or dividing, we can write them under one radical, or we can split them up and write a radical over each of them. Usually our whole numbers go first, and our radicals go second. We've got 3 root 10. So our whole numbers go in the front, and our roots go second. All right, so we've got square root of 60 plus 3 root 10. What perfect square lives inside of 60? It is a perfect square that lives inside of it. 4. 2 and 30, 2 and 15, 3 and 5. So 60 can be written as 2 times 2 times 3 times 5. The pair is that 2 times 2, which is 4. So we can rewrite 60 as 4 times 15. Let's go ahead and take the square root of that 4 and move him out of the square root prison. He's like, see ya, 15. I'm out of here. So he moves out and becomes a 2. 15 stays inside. Incarcerated. And now we can't do anything because it's got to be the same radical in order to add them together. So we just keep 3 root 10, and we have now a 2 root 15. When they're asking you to simplify, you have to, if anybody is in the square root prison, that's a perfect square. You have to get them out of there. Otherwise, you're not in simplest form. Okay, watch this, crazy kids. So we're going to multiply both the root 6 by root 6 and the root 3 by root 6. Then the next step is going to be negative 2 root 3 times root 6 and negative 2 root 3 times root 3. So we are going to multiply everything with each other. When we did this with our polynomials, we made a little box chart. I'm not going to make a box chart. I'm going to just do first inside, outside, left. FOIL. So I'm just gonna write it as it is. So it's root 6 times root 6. It's root 6 times root 3. Then it's negative 2 root 3 times root 6. Oh, I'm running out of room. Wheels. And then it's negative 2 root 3 times root 3. Okay. If I have multiplication and something is under a root, I can write it all under the same root. So this is root 6 times root 6. I can write it as the square root of 6 times 6. This is 6 square root of 6 times square root of 3. I can rewrite that as square root of 18. Oops, sorry. Just skipped a step there. Negative and a positive give me a negative, so that's going to be a minus instead of a plus. We have the 2 is on the outside, he stays on the outside. 3 and the 6 are under the root, they go under the root. Negative and a positive give me negative, the 2 stays out front. And the 3 times 3, because both of them are underneath the radical, go together under the radical. All right, let's simplify these down a little bit more. 6 times 6 is 36. 6 times 3 is 18. 6 times 3 is 18. 3 times 3 is 9. Who's the perfect square in this universe? Who's perfect? Let's go. Where are we at with my bingo? No, we're at John. John, who's the perfect square in this string of numbers? Who is perfectly square? Huh? 9 is perfect square, yep. Square root of 9 is 3. And Brendan? Who's the other perfect square in this? Yeah. 36 becomes 6. Same root, so let's go ahead and put those together. Okay, Rachel, are you ready? Positive root 18 minus 2 root 18 is how many root 18? Yes. Okay, here's a little trickster. We did root 18, didn't we? Who was that? Didn't we do 18, right?
2 times 9 is right there.
Yeah. Boom. We did that. 18 has a perfect square living inside of it. It is 9. So we know that 18, so let's write this out, is going to be 2 times 9. Let's pull out that perfect square. So square root of 9 is 3. Root 2 has to stay there. And what is 6 minus 6? 7. 0. So when I have 6 minus 6, it's going to cancel it out. And my answer is negative 3 root 2. Who knew? This big thing was going to foil out to be just negative 3 root 2. Who knew? I don't know. Really? All right, I'm going to give you guys 90 seconds on the clock to get these two problems a whirl. All right, Connor, what did you get for the first round you tried?
So I took the square root of 2, raised it to square root of 6,
Uh-huh.
got square root of 12 plus 5, with the square root of 2 became 5.
Mm-hmm.
And I simplified the square root of 12 to 2 to the square root of 3.
Okay, because perfect square 4 lives inside.
Yep. And I added 5 square root of 2.
Perfect. Thank you. Right, we're ready for easy. We'll give you hard. All right, so we have square root of 6 times 4 root 3. So I'm just going to write that down. So who's in the roots right here? Who are in the roots? Okay, so we're going to combine them underneath one root. What is 6 times 3? She's laughing at 30, not you. Fine. Guess how far out? What's 6 times 3? 18. Okay. And then what? We've done square root of 18 before, so what perfect square lives inside of 18? So what do we get when we take the square root of 9? 3. Yeah, so the 3 is going to come out and multiply by the 4, and the 2 is left inside. So our new front number is going to be 12 root 2. That is 1 out of the 4 new numbers. Alex, are you ready for the second one? So we got root 6 times 3 root 6. So let's combine the root 6's together to give us the square root of what? Mm-hmm. But that's a perfect square, right? What does that give us? Uh-huh. So then we have 3 times, oh, hold on, we need one more level up. And voila, we have 3 times 6 again. What is that? 3 times 6. 18. Okay. Next one, Gavin, this is you. Okay, we have negative 2 root 3 times positive 4 root 3. That's going to give us a negative and a positive. So what is my front number when I multiply my front numbers together? Yep. Well, what?
Multiply them.
Yeah. And then we're going to put we're going to put those root 3's together. So what's 3 times 3? 9. Is 9 a perfect square?
Yes.
It's right there. What is square root of 9? 3. And what is 8 times 3? Okay. All right, Lance, last one. You got this. Last one. Okay. Negative 2 root 3 times positive 3 root 6. I have to write it right here. Negative 2 root 3 times 3 root. You help me with it. So Lance, what is 2 times 3? -6, that goes out front. And we're going to combine our roots together. It's going to be root what? Yeah. 18 has a perfect square living inside of it. What perfect square lives inside of 18? It's 9. So it's the 9 times 2. And then what is the square root of 9? 3. So we're going to take the square root of 9. It's going to be the 3. Put that out front with the 6. And we're left with root 2. What? Okay. And then what is 6 times 3? 18. Okay. Yay, although I don't remember. I haven't done cold in a row. Ready for this?
Yeah.
No.
Okay. 12 root 2s minus 18 root 2s. It's fine because of the root.
6 root 2.
Mm-hmm. So we take care of that. We can cross it out. And then what is 18 minus 24? Mm-hmm. -6 minus 6 root 2. If you are not a fan of writing things down, and you love skipping steps, I don't recommend you do that for this process here. At least not until you get good at it, at radical expressions. Oh, fiddlehead fern. Fiddlehead fern. They use those on Chopped all the time. I can't believe people eat them. But okay, fiddlehead ferns, sauteing some butter. Delicious. Fiddlehead fern naturally grow in spirals that fit into golden rectangles. Golden rectangles have ratio of length to width of 1 plus root 5 to 2, length to width. So on your problem, put length, L, and put W. Okay, ready? Sorry. So we want to know what's the width of the fern shown here. So we know that the length is 4, and the width is a nib. So length to width, let's put the length on top. So 4 to W equals 1 plus root 5 to 2. Diego, what do we do with the ratios when we got two fractions that are equal to each other? How do we solve that?
Wait, what?
So I've got two fractions that are equal to each other.
Yeah.
How do I solve that? Anytime we get fractions that are equal,
Multiply.
we are going to multiply, but which items go together?
Oh, 4 and 2 and W.
Yeah, so we cross multiply. We go diagonally. So we got 4 times 2 and W times 1 plus root 5. All right, so 4 times 2 is 8. And I'm going to distribute the W. No, I'm not going to distribute. I'm not going to distribute the W. Not distributing the W. Send that memo. We are going to just leave it as it is. There's too many W's running around, it's going to mess up my brain. Okay, so let's, we're on Morgan. Opposite of multiplying is dividing. We're going to divide both sides by what? We divide both sides by 1 plus root 5. We will get the answer for W.
That's the answer.
Does it make your heart cry a little bit? Because we can, all this is numbers. We can go 8 divided by 1 plus the square root of 5. So the width is approximately equal to 2.47 centimeters. That make your heart a little happier? But sometimes we're not going to get whole numbers. The reason we keep radicals in their radical form is so that we don't have to write the bunches of decimals and carry that through our problem with us. Okay, a golden rectangle is 12 inches long, so let's go ahead and draw the picture. Its length is 12 inches. We don't know the width. Using the same process as we did up here, what is the width of the rectangle? I'm going to give you guys 60 seconds. All right, our setup is going to be similar to the one we did here, where we have, but instead of 4 over W, we are going to have 12 over W. One plus root 5 over 2. And we're going to cross multiply. 2 times 12 is 24. And then W times 1 plus root 5. So we're going to divide both sides by 1 plus root 5. You can stop there if that makes your heart happy. So W is equal to 24 over 1 plus the square root of 5. Or you can grab a calculator and go 24 divided by parenthesis 1 plus the square root of 5. And that's about 7.4. Inches. Okay, what else we got, guys? We're on the summary. Okay, so on your summary, please describe. How to combine radical expressions. When adding and subtracting. And then explain how to use FOIL find the expression when you multiply. That should give you should do at least 2 sentences on each one of those bullet points. When you are done with your summary, You then need to work on the 10-3 practice, which is on page 629. It's 9 through 19 odds, 2 through 22 evens. If you finish that, then you guys need to do the 10-3 classwork. If you finish both of those, double check your 10-1 and 10-2 practice and classwork. If there's anything on there that's unanswered, go ahead and fill that in. And then if I would like to reserve the last 20 minutes of class to do a Kahoot activity on radical expressions. All right, so write your 4 sentences, 2 on each of these bullet points. And then I will put up the book in just a moment.
Chill.
You, hold on just a second. Give me just a second. Dean, I need you to take a moment, put your feet on the floor. Close your eyes, take a couple deep breaths.